I'm Dan Dye from Google Cloud Security. Today I'm going to demonstrate how to build and deploy a Gemini Enterprise custom agent that uses the Google Cloud Security MCP tools and uses Retrieval Augmented Generation, or RAG, for a full set of agentic SOC runbooks. Those runbooks turn a large language model agent into a full-fledged SOC analyst. They provide the agent the knowledge needed for threat research, threat hunting, alert triage, containment, eradication, SOAR playbook execution, and much, much more. While the runbooks provide the knowledge, the Google Cloud Security MCP servers provide the tools to perform that work. These MCP servers are currently packaged and built into the agent, so they're running right alongside it. Google will be providing hosted versions of those agents soon, but you don't have to wait. You can use these tools today. I've previously shown these tools and runbooks running with ADK Web, that is Google's Agent Development Kit, and I encourage you to check that out. The two things that I'm showing you here today that are new is one, putting the runbooks into a RAG corpus. RAG is the format that agents crave. The RAG corpus is deployed to Vertex AI, and I'm deploying this agent to Gemini Enterprise. Gemini Enterprise is the answer to all the questions I've been asked about security and governance. Up to now, my response has been that I'm showing a preview of these tools for early adopters, and I do want to stress how important that is. Developers need time with tools to gain proficiency, so giving us a safe space to experiment is critical to success. I was dropping hints that Google Cloud Security's big brother, Google Cloud, was tackling the challenge of making these tools enterprise ready. Big Brother has delivered, and it is Gemini Enterprise. With that said, what I'm showing is building and registering a custom ADK agent in Gemini Enterprise, which is a cutting-edge feature still in preview. In addition to the configuration of the agent itself, I built a lot of tooling for this, and I've published it on this new GitHub repo, Agentic SOC Agent Space. The tooling is a set of Python utilities that separate the code and configuration of your agent. The configuration is put into a single .env file, and a make file wraps the Python to provide a single interface for the whole process. As you'll see in the walkthrough that follows, there are quite a few steps in that process, but I can give you a high-level overview here. Previously, we were packaging our custom ADK agent up into a container and deploying that container to Cloud Run, which we manage ourselves. With Gemini Enterprise, a fully managed container is built in Cloud Build, and it's hosted in Agent Engine. Then we create a Gemini Enterprise app, and we link the Agent Engine to that app. My goal with the tooling was to enable this with three build targets, three make targets: Agent Engine deploy, Agent Space create app, Agent Space register. Once done, the Gemini Enterprise app has the stock agents like deep research, idea generation, and Notebook LM, and it has the custom agent that we've defined ourselves, the MCP security agent. That custom agent can then answer questions like, what's the objective of my malware incident response plan? By retrieving the runbook content from the Retrieval Augmented Generation corpus. Even better, it can go full agentic with a prompt like, execute the malware incident response plan for case 1, 2, 3, just like we saw in my previous demo. In the demo that follows, I will start with a few sessions that show the RAG and MCP tools put through their paces. After that, I'm going to walk through the process used to create this custom agent. I've got some pro tips on the development and testing process that should make your custom build much easier. For example, the build and delete make target helps you iterate without accumulating dozens of non-functioning agents, and the get logs make target gets you the stack trace on why your last build didn't work. So if you only intend to be a user of Gemini Enterprise agents, you might bail out of the video after the demo, but stick around to the end if you are a builder. All right, so I'm going to do a walkthrough of Gemini Enterprise, which I have deployed onto this tenant. So first, I'm going to search for, oh, there it is, Gemini Enterprise from the list of apps. And you can see I've done this a few times. I've deployed this recently. I've got 2 in global, and then the most recent one deployed in the US location. And you can also see that I've got a connected data store for this one in the US. to look at the list of the data stores that are configured here. My first attempt was to put the runbooks into Google Drive, but I later realized that I'd be better off with them in Retrieval Augmented Generation. So got that data store configured, but it's not in use at the moment. What I'm using instead is the RAG corpus, which I can also show in a bit. But let me go ahead and click through, and some of the things that you can see, this is an app, and this is the app identifier. You can see that there is a unique URL for it. You can see that there are connected data stores. There are actions that I don't have set up. There are prompt chips, which I don't have configured. The configuration for this particular tenant, you can put your own logo in the top left, for example, change the preview. The agents that are associated with this thing. So I've got the stock idea generation, the stock deep research. And what I'm really interested in showing here is this MCP security agent, because this is a custom agent that I have written and configured for this project. Now, I've been showing this MCP security agent in ADK, running an ADK web, and hosted on Cloud Run, for example, but having it here hosted in Gemini Enterprise is really a killer feature. It is fully managed. It has a lot of security and tracking. I would really defer to the developer relations at Google Cloud for speaking to all of those things. There are a lot of features in Gemini Enterprise, and I'm really just focusing on the security features here. So you can also see that, again, here's the link to the web application. It's the chat box for it. There's the API interface for it, which is very interesting to be able to integrate this agent with the API, and then analytics for it. So I think what we're really going to look at here today is the chat interface initially. So let me copy that URL. And then I'm going to paste that, and here we are. So this is the landing page for it. And this was a little confusing for me at first. I wasn't sure which of the agents I'm chatting with, but you can see over here this list of agents, and then the ones that are pinned are here in the sidebar. So if I click on this one now, I can be 100% sure that I am chatting with the MCP security agent. And let me go ahead and, rather than you watch me type, I'm just going to paste in. The prompt is get the objective from the malware incident response plan. Objective is one of the sections in the IRP, and the IRP is a markdown document that is a part of the AI runbooks. It's like 3 directories down, so the whole directory structure of the AI runbook or the Agentic SOC runbook GitHub repo is kind of reproduced in the RAG corpus. And an interesting thing, first, it does identify, it pulls out, extracts the objective from the malware incident response plan. And then what's really interesting is that you get these links to the document itself. And if I click on that, I am downloading that document locally, and I can open that in a text editor and verify that this objective is what I'm looking for. And then it's also got this link to runbook orchestrates several specialized runbooks, and then it lists those as well. So yeah, we've got the sources that are associated with this. In addition to doing the retrieval augmented generation and extracting the text, we've got the sources. So that is an example of RAG in action and doing retrieval. Let's next look at the MCP tools. So my go-to for this is list SOR cases. And this should be an MCP tool call to the SOR MCP server. And I believe that the tool within that server is list cases, list underscore cases. And what I'm expecting to see back is most likely a bullet. Oh, there it is. Yeah, list cases is the name of the tool that is being run. And what I'm expecting to see back is a bulleted list of the cases This is non-deterministic because the list cases tool is going out and getting JSON from the source server. When that JSON is returned, the agent decides how best to display this in the most meaningful way. So what it's decided to do is start with case ID, and then display name, and then status, and then priority. I've run this tool quite a bit. Sometimes I will see it, some of the cases will be clustered by priority, for example. It is possible to be more prescriptive in how that's displayed. You could do that either through prompt engineering. That could be something that you have in the RAG corpus, for example. Or you could give more explicit instructions for how you want it displayed in the tool. The doc string for the tool, for example, would do that. But let's go ahead and let's pick one of these. Yeah, this is a good one. So I'm going to take this one and just say, very open-ended, investigate case 4479. So we've seen a tool call that was fairly prescriptive, list sort cases, maps to a single tool. An open-ended query like this, investigate case 4479, doesn't really map exactly to a single tool. So the agent is going to make some decisions about how to proceed here. And we saw that the first tool call was get case full details, and here's the summary for it, and the alerts, and then here are some suggestions for follow-up. This is a good one. We saw an alert ID in here, and we can go ahead and query that. The alert is for FirstNet malware DNS, and it's associated with the case. And there's a chronicle detection. There's the rule identifier, identifies events aligning with FirstNet. The alert has 5 severity, so the alert status is open. So that's all good. Let's see. Here's a nice one. Can we summarize the FirstNet malware? Now, we could get a call to the Google Threat Intelligence MCP server at this point. That would be one way. We could also get that from the case. The case may have some details. Or we could get, I do not have specific information. There's that as well. Oh, here we go. GTI, get collection report if a specific GTI ID is known. Okay, yeah, so that's not going to work for us. Although maybe search threats. Let's see. Let's just ask this question. How do I use GTI checks to identify malware families? And we'll proceed that way. I think the next query I'm going to run is you can use Google Threat Intelligence to identify malware families. Again, collection ID, collection report, MCP get file report. Maybe if we had a file hash. So I think if we had a file hash, we could send that to the GTI server and get some details. That would be one way. Another query I want to run is list tools with FirstNet in name. So I know that this is going to map to the SIM server. There are 4 MCP servers packaged here. They are for the SIM, for the SOAR, for Google Threat Intelligence, and for Security Command Center. And to put this through its paces, I really want to hit at least one of each of those. So let's see. Based on the specific information, a specific hash is not provided. Runbooks indicate that if a file hash were available, it would use the GTI tools to identify. So yeah, it would be nice if we had that hash, but we don't. Let's go ahead and run this one and see if we can get a response from one of the other servers. This is going to be the SecOps SIM APIs, or these are, I think, technically called the Chronicle REST API. Chronicle REST is the one that is used by the MCP server, and it actually uses it through the SecOps wrapper library. It is an SDK for interacting with that Chronicle REST API. So you asked to list rules with FirstNet in the name, and here are the results. And indeed, I do get the 3 rules, then I know these to be true. This is interesting. We get some, Okay, that info also happens to be in the corpus because I believe that I have a list of the rules in the malware corpus as well. Let's expose thinking and see what happened here. So search security rules starts and finished. Okay, and it did find them that way as well. That's interesting. So found it a couple of different ways. All right, well, I think we've been through a few of the different MCP tools. I'm going to switch over now to show how I went about building this this agent and deploying it as well. So I'm going to switch over and share some code. All right, as I mentioned in the intro, I am going to walk through some of the code to construct and deploy this agent at this point. And you may want to bail out of the video if this is not your thing. If it is, well, please stick around, and I'm going to show you how this agent is constructed, how it's deployed, and walk through some of the lessons that I learned while doing this work, how to make life a little bit easier. So at the top, this is main.py. So the agent is mostly defined in this. The MCP servers are in a Git submodule. I can show that. So they're here, and this is a submodule. So you can see it is from a remote repo, and it's a dependency in this. And next we've got this load.environment. So I worked hard to separate the configuration from the code in this and put everything into a single .env. Like here, for example, the Chronicle service account path rather than the file itself. Still, it's a good practice to add the .env file to git ignore. I believe it is by default. There's a .env example that you can use to copy over and see what things you need to configure here. And some of the documentation is here in main.py. That's repeated in the .env example as well. Actually, I guess I should show that. Here we go, .env example. So there's fairly heavily commented, and then the things that you need to configure are commented out and with placeholder values. Now, these other things, the RAG corpus name, for example, these do need to be configured before you do your deployment. I've got some convenience tools for that, and I guess now's a good time to show those. Let me zoom out a little bit, get more real estate, and show the make targets. So if I run make with no commands, you get the list of the make targets. And I wanted to show this zoomed out because it's really pretty. And then I'll zoom in to show some details. Now we got some line wrapping, so it's not so pretty anymore. But the important thing for you to see here is the RAG corpus management collection of tools. So you, for example, list the existing and then create a new one. Now, I showed that there was a submodule for the MCP tools. There is also a submodule for the AI runbooks. So that is also provided as a part of this repo. So that's the RAG corpus. And switching back to main.py, let me zoom out. Oh, that's in. Zoom out a little bit. All right, so we've got all of these global environment variables set, and then we start configuring these MCP tools. So if you are a user of the Google Cloud Security MCP tools, you may recognize this configuration. Looks very similar to what you may have configured in Gemini CLI or in clients like Clyde. So it is very similar. You've got UV. I generally recommend the absolute path to UV if you're running this on a client locally. This configuration does do the work to ensure that UV is on the path, so you don't need the absolute path. This is the relative path to the directory that contains server.py. Now, on the MCP tools repo, we've got a fairly recent update where we enable the use of UVX instead of UV because all of these packages are on PyPy as well. Not used here. This is using kind of the older method of find the path to server.py. So there should be underneath this directory a file server.py. And this is where those environment variables get used. So this is to configure the MCP tool, MCP server. As it uses the Chronicle API, these are the things that are required. So the project ID, the customer ID, the region, and then instead of using the application default credentials for this particular deployment, I have it configured to use a long-lived service account file. Next, we have configuration for the SOAR MCP server, and it is very similar. UV, path to server.py. Next, we've got the GTI server, same thing, server.py, API key, and SCC. And then we've got one that's commented out. As I was developing this, I was working on using, my first attempt was to use the AI runbooks as a data store. And it later occurred to me that the retrieval augmented generation was a better solution for that. Didn't want to lose my work though, so I just commented out the block. So that is not in use. And this is the configuration for that, that RAG. So the RAG corpus name, that global environment variable that we set at the top, is used here, as is these two configurable parameters. And this is the path to the RAG corpus. So this contains the AI runbooks that are in the submodule for this particular GitHub repo. Next, we have the configuration of the agent, and this is an ADK agent. So very similar to when we were doing deployment to Cloud Run or running an ADK web. I don't have this as configurable, so you can't set this in the .env file, but if you want to change this to Flash, that also works quite well. I'm sorry, change it from Flash to Pro, that also works quite well. The tokens are more expensive, so I did want to default to using the cheaper option here. Now, the description and instruction, I have found prompt engineering is something that takes a lot of time. So this is working, but I definitely could iterate on this and get some improvements. One of the things I have noticed is if I'm trying to get an agent in Gemini Enterprise to do a full workflow, it comes back and prompts the user too many times. So that's something that I might experiment with improving in this instruction to say, do as much as possible without, do as many steps as possible without prompting the user. Just encourage it to be a little bit more autonomous. Now, here we've got the list of the tools that we defined above. Again, commented out the data store tool, and that was a Vertex search. So that would have retrieved the runbook from Google Drive was the data store that I had configured. And instead, using this, the Vertex AI RAG there. Next step is to initialize a Vertex AI. The service account path, the service account file is not packaged. It needs to be inside the container that is deployed. Actually, I say needs. It may be possible to deploy that through a Cloud Secrets. I haven't experimented with that. This is fairly new work, so this is what I've got working, is to go ahead and copy that into the directory for the MCP server that expects it, and that is the SecOps SIM MCP server. That server normally uses application default credentials for authentication, and the code that is in the submodule is updated to instead use the service account path. Now, this is this was just for debugging. What gets deployed is not main py as you see it. when this gets packaged and built in Cloud Run, it's pickled. But I found as I was deploying this over and over again, I wanted to have a permanent record of the state of this file. So I just put a copy of it into main.txt, and then I have it inside the pickled application, which made it a little bit easier for me to do some troubleshooting. One of the things I also found is when I deploy an agent over and over again, I was iterating and debugging, I saw that the files in the cloud bucket that are used to stage for the cloud build are overwritten. When I had a working one and then broke it, I found it was not too difficult to revert to the previous one and then download and unpackage and explore the contents of that. So that is a bit of a pro tip. Here we have the ADK app being configured, and not much here, but the root agent is specified that we built above. Agent engines create. Now, this is the step that this is a not Python code that gets executed as part of your agent, but instead, when you execute main.py, at this point, it has the app in memory. It has just constructed this. This step is sending that app. So first pickling the app, tarballing the dependencies that go with it, and it is sending those to a to a GCP bucket. And from there, Cloud Build is constructing a container, a fully managed container that lives inside of Agent Engine. So what you're creating is an engine, or is also sometimes called an app. That's a little bit confusing. I would like to be more consistent in just calling it an engine all the time. So the display name is SOC Agent Engine. You can see this is a debug one. So I have the let's see, month, day, hour, minute of that deployment to help me differentiate it from the others that I did at the same time. Excuse me. These dependencies are very important. The build that I was working on had a bug with maybe 1.18, so I really needed to strongly pin the version that is above that to get past that bug. And I believe that's a little note about which bug it is. Now, in the documentation, you'll also see Google Cloud AI Platform, square bracket, ADK, like so, ADK, comma. What that does is it installs this Google ADK as a dependency, and you do not want to do that right now. It is better to explicitly specify the version of ADK that you want, because you don't want to run into this bug, and this is the version where that is fixed. And here I'm more explicitly specifying the version. So I have removed it from this dependency, and I've put it higher in the list of requirements. And with this, I'm able to guarantee that I'm getting the version of ADK and the version of AI Platform that fixes the bug that I was troubleshooting. And that's some of what necessitated me building several times, was troubleshooting that bug. So strong pinning of the versions of these dependencies. Now, this install script, I mentioned that UV needs to be on the path, and that's what's happening here. So this is a file that is a part of this repo, and it is doing the installation and configuration of UV as part of the build option, so that UV is available when the MCP tools instantiate. Extra packages, this is saying this whole directory and all of its subdirectories, which have all of the MCP tools, is a part of this, as is this single file in the installation scripts. So this ensures that the pickled application gets everything that we're looking for. Lastly, we have the environment variables. This is an interesting one. This is ensuring that we're using the Vertex AI version of the large language model, not using the was it AI Studio version. So this is just true. It's just a Boolean. So that is all that's required. At this point, the agent engine gets deployed. This step takes a while, maybe 5 minutes or so. And when you get to line 252 here, you now have a running agent engine, hopefully. So the next steps that I have are to, one, test the agent. And that test is done by sending a prompt. This prompt, you can see I've got a couple of different prompts that I've experimented with. This was the thing that I guess I was troubleshooting last, was ensuring that the RAG search was working. And this was another one where I'm ensuring that the authentication and MCP tool configuration for the SecOps SIM MCP server was working. So immediately after building, run this test, and either you get no results or you do get results and you get the output from that. So if everything goes well, you see at this point around line 279 the output from the agent's response to that query. And if you see that, then you have a working agent. If not, I'm sorry. Oh, and this is the point at which this asynchronous function gets called. So it's wrapped in async IO, and you can see that this is an asynchronous function. But you will at line 282 have the result of that test, and you know whether or not you have a working agent in Agent Engine. Now, I could have been a little smarter about this and set a flag and only run delete if it failed, and kept it if the prompt was there. Instead, what I did is just parameterize it. So when you execute the build, you either do or you do not provide the delete flag. And this is useful, this cleanup. I was running, I mentioned troubleshooting these dependencies, so I had to run the build several times and started accumulating Agent Engine instances, and then had to go in and clean them up. So this, as you're troubleshooting, you can supply the delete flag, and then it does this build, test, delete all at once, and gives you about a 5-minute turnaround for make a change and then find out if it worked. And if it does work, just repeat it with the delete flag dropped. Prototyping and testing a little bit easier to do. That is also wrapped. You can call main.py from Python, or you can use the makefile target. So Agent Engine deploy will call this makefile, and then Agent Engine deploy and delete will call it with that -- delete flag. So this is a single param for that testing. You can edit main.py, run this, and just do that in a loop so you've got it working. All right, so that's about it for main.py. I guess the other things that are important to know here, in addition to deploying to Agent Engine, you need an agent space app. So you can list the existing agent space apps. You can create an agent space app. Once that is there and you have the app and the Agent Engine deploy, register is what ties the two together. So it's what gives your app that new agent. We saw in the walkthrough and the demo that there were the built-in agents, and then there was this custom agent. So to add that custom agent to an existing app, if that's done with this register right here. And then there are a few other conveniences in this repo, like creating the RAG corpus, creating the OAuth, and associating the OAuth with the agent space. I'm sorry, I'm going to say agent space over and over again because the Gemini Enterprise is still very new to me. And I believe it was released last week or week before. So when I did all of this development, it was still using this name, agent space, but Gemini Enterprise is the new name for agent space. So yes, associate the OAuth with a Gemini Enterprise app. It is with the OAuth, and these are just some workflow for kind of wrapping up sequences of those things. That's one. It's very tempting with makefiles to just, for example, say the last step, agent space register, and then create a dependency on that it must have done this agent engine deploy, and it must have done the agent space create app. Those are both prerequisites, and if they haven't been done, go ahead and do that. It's tempting, but it's a little too magical for me. I'm trying to create this code as a reference implementation, communicate the requirements as well. So I opted not to do that whole chain of tools, but there are a few of them wrapped up into some workflows here as well. A few other things. So some of these tools do take kind of parameters like log level, force, how verbosity, path to the environment file if you're experimenting with alternatives to the environment file. So yeah, the agent, this agentic SOC agent space management is a suite of make targets, and those are basically just wrapping these installation scripts. We saw install.shell is it's getting the UV binary, and then these things are not packaged into the running agent, but these are the utilities that get used by those make targets. The make targets just turn around and call these things. You can call these from the command line as well. So we've got the installation scripts, the AI runbooks. This is what's in the RAG corpus, MCP security. These are the servers. These are both submodules, Git submodules. Got a virtual environment. Let me speak to the virtual environment for a bit. The requirements here, you can see actually I was experimenting with upgrading from what was defined there. Well, I think I had less than or greater than. So this is strongly pinning to the version right above it. And this is also strongly pinning to the version right above it. So believe I'll have and this worked. So I believe I will have this in the GitHub repo in the main branch pretty soon. This is a feature branch we're looking at here. But this is specified as a .env file, and this is the same set of dependencies that we saw on main.py. Now, if I do pip compile on this file, what I get is the complete list of the dependencies of the dependencies. And this is the complete list, and you can see every single one of them is strongly pinned. So this is a nice convenience to have these at the top level with what I know to be requirements for not just floating. You can get any version of Gen AI, but you need this version of AI platform. And then this gives me real reproducibility to ensure that I've got the exact version of every library, because these things change and you never know when they're going to break. Lastly, I've got the README, which is on the GitHub repo as well. It has the steps to get this installed. I mentioned that you do need to recur submodules when you do the initial git clone. That gets the contents of the AI runbooks, MCP security, copy the environment file to a new env file, and then edit it to fill in your own credentials and identifiers, create the virtual environment, install the more robust version of the requirements, and then make agent engine deploy is that step to build, test, and possibly delete, if you had deploy and delete, the put on agent engine. And the way to test agent engine is, again, through the API. You use the API to send a sample query and get that assurance that it works. All right, I'm going to wrap it up there, and I hope that you check this out and leave some questions, comments on YouTube comments and on the Google Cloud community forums if you have any feedback on this. Thank you.